Hi, welcome. So this is going to be a video about how to graph using Google Sheets. So what we'll do is I'll start going. The idea is that as I go, you'll be able to play and then go back in the steps you missed. And this will be using the data you have seen in class for our modified Atwood's machine. So here I go. So the first thing I'm going to do is move the data provided into Google Sheets. So you can drag and drop columns to change their size. And notice that I'm putting the heading for the data too. And you'll see why later. I'll double check to see if I have all the numbers right. Look good there. And then I'll add the second column of data. You always want to set up your data table so you have the variable you want graphed on the x-axis to the left, the variable you want graphed on the y-axis to the right. So that's why I'm putting acceleration to the right of the gravitational force of the M2 hanging mass here. And notice not only am I providing a label, I'm providing the unit too, which is always helpful when we start to interpret the graph. All right, so I have my data moved over. So now time to make my graph, and hopefully this looks like a graph that you would produce on paper. So I'm going to start by highlighting my data. So that is a click and a click that I drag to get all the boxes blue. Once all the boxes are blue, I hit insert and then chart. We prefer this type of graph in science, what's known as the scatter plot graph. So notice I'm on scatter chart here. If, for example, you got a different suggestion from Google, let's say a line chart, you would click to get the scatter plot, just like that. So I have a graph. Notice by placing those headings, I already have each axis labeled, which is super handy. So now what I can do is, just like you would do, I can identify a trend through the data. This data to me follows a linear trend. And to work with that, this is what I'll do. So I'll click on a dot. And when I do, it brings open what's called the series information right here. And let me move myself to the other side of the screen. So it brings up the series information. And I'll scroll down until I hit a box that says trend line. And I'll click trend line. And that pops that trend line right up. And then I'm going to add two things that really make our lives a lot easier. One thing is Sheets will provide the equation for you, so you don't need to calculate slope or intercept or do things like that. So I'll go use equation, and notice that equation populated right at the top of the graph there. So here I have a slope of 1.22. And we'll talk about later about what that means. And I'll go called show R squared value. The R squared value is how well your data fits the actual trend line that's being provided to you. Here at a value of 1, it's about as high as you can get, showing that this data fits the linear trend. The equation that we build is going to be true for the data. So here is our graph. And you can kind of stop there with that. So let's work on the other one, which is acceleration versus system mass. So I'm X out here. I'm going to scroll down a little bit on my screen. So this is right here. I'll scroll down a little bit, and I'll place my next one. So system mass kilogram acceleration meters per second squared. Make that B a little bit bigger so I don't have that annoying line in the way. And I'll move over my system masses. Now accelerations. All right, so there's my data moved over, and I'm going to follow some pretty similar steps. So I'm going to start with highlighting my data. Move myself over there for now. Once I have my data highlighted, remember I clicked and dragged that click without releasing. I go Insert, Chart. And once again, it's suggesting the chart type that we want already, which is a scatter chart. But here, we realize something that's going to be important to us. When you look at this data, when I look at it, I no longer see a straight line. I see a curve that's coming through the data. Eventually, you'll take a math class, or maybe you already have, to realize this is a graph type called an inverse graph. And we're going to look at how to deal with this type of graph to gain a better understanding of it. So could we do some steps here to understand it right here? Yeah. We're going to go through one additional step, though, which will be able to utilize the math you know to understand this a little bit better. So what I'm going to do is I'm actually going to get rid of this. So I'm just going to delete out it. Because I'm going to do a bit of a change down here. So to do that, I am actually just going to take my data again. And I'm going to copy it. So I highlighted it and I go to Control-C to copy it. And I'm just going to paste it over here to the side so I can work with it a little bit more. What I want actually now is I want a column in between system mass and acceleration. So I'm going to go up to E, and there's a little down arrow, and I can go insert one column to the right. Let's get that graph out of the way. And I'm going to title this column differently. So to deal with that problem of that curved graph that I know is a graph type called inverse, is I'm going to perform that inverse operation to the x-axis, and we're going to watch what happens. So instead of graphing system mass, I'm going to graph 1 over system mass. And now, instead of the unit being kilogram, it's actually 1 over kilogram, because I have to inverse that mass unit too. Let me make that column a little bigger so you can see the whole thing. And this is where the real magic happens. Instead of having to go type in my calculator, 1 divided by, for this first one, 0.799 equals, put the number in, I can let the computer do all that math for me. That starts by hitting the equal sign. You'll notice an equal sign populates in the box I'm in, also up in this function bar. And I'm going to tell it I want to do 1 divided by that system mass number. And after I'm going to hit enter. And it's going to suggest to me that do I want to use that formula again and again, but with the number that's to the left. Notice these numbers are changing each time. And you can just hit check. I'm going to hit the X just in case it doesn't give you that suggestion, so you know what to do. So I'm going to hit X just to show you. And I'm going to click on the box, and then I'll drag the bottom right corner of the box down and it gets you that same spot where it moved that formula we produced and did all the math for us. Now what we're going to do is we're going to take these two columns, our new x-axis, which is 1 over system mass now, and we're still going to graph acceleration. And we're going to do it. Remember, clicked, drag the click. We go insert, chart. Ooh, look at that. Okay. And let's see if this is linear. So I have already the scatter chart that I want. I click on a dot. Brings up in the series information. I scroll down to hit trend line. It already recommends a linear trend line. Linear line looks pretty nice there. And instead of label, I'm going to go use equation. So it provides me my slope value. And I'll go show r squared value. Notice that r squared value is 0.999. The best you can get for an r squared value is that one we saw before, saying that the data exactly matches that linear line that the computer is producing. This is only 1,000th of a way for real data. This is really good. So we got our second graph here. So I will move myself over here for now, get out of this chart editor. And by the time you're done, kind of do that. Move this graph here, and you'll notice I'll have two graphs. One graph of acceleration versus the gravitational force of M2 hanging mass. This is going to be what we're going to essentially call our pulling force, but we'll get into more what that is. And then a graph of acceleration versus the system mass, or 1 over the system mass here. And we'll look at how that changes the equations, what we can learn from those equations. But see if you can do that, and then ask your teacher for further instructions.